Hello, myself Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss the outcome-based education regarding the course Computer Organization and Architecture. What is OBE? OBE is a student-centric teaching and learning methodology. So here, before olden days in the traditional methodology is the teacher-centric. So the participation of student in the active classroom events can be minimized. So OBE focused on the student-centric teaching and learning methodology in which course delivery, assessment are planned to achieve stated objectives and outcomes. For each course, the course objectives and course outcomes are predefined, and this methodology can the delivery concentration on the delivery of the course and also concentrates on the evaluation methodology whether these objectives and outcomes are reached or not. If focus on student performance, outcome at different levels can be achieved. So OBE is defined as the process that involves assessment and evaluation practices in education to reflect the attainment of expected learning and showing mastery in the program area. So why this OBE can be required? For international recognition and global employment opportunities, for better visibility and reputation of the technical institutions, for more employable and innovative graduates with professional and soft skills, social responsibility and ethics, and also improving the involvement of all stakeholders. The stakeholders for an technical educational institutions can be the students, faculty, parents, institutions, various universities. So, enabling graduates to excel in their profession, preparing graduates for the leadership positions and making them aware of the opportunities in the technology development. So, general traditional education process can be give the input, teaching staff, curriculum, labs and other sources, and teaching and learning can be carried out as the process. So assessment mainly with the help of exam, test, assignment, quality control from teaching evaluations can be carried out, and students can be graduated as an output. But with the involvement of the OBE, the input has to be given by the teaching staff, curriculum, labs, other resources, the process teaching and learning, and after graduation also the outcome can be evaluated. So here the process is concentrating on assessment by exams, test, assignment, assessment of teaching staff, lecture materials and flow, results and students' capabilities. The short-term and long-term capabilities and outcomes can be assessed. Lab interviews, exit surveys can be conducted. More thinking projects with analysis. Feedback from industry, alumni and other stakeholders. Clear continuous improvement steps can be involved in the input as well as in process and during the student at graduation. The short term can be the assessment of program or course outcomes assessment. The long term can be the PEO, that is the program educational output. So this is outcomes. So the graduates to feel stakeholders' satisfaction. The stakeholders can be the employers, industry advisors, academic staff, public and parents, students, alumni. By taking the feedback, the long-term the program educational outcomes can be assessed. And this is the outcome-based education process. So, what is the difference between traditional education and the outcome-based education? The traditional education can graduate or rank based on assessment. And graduates are derived from points on activities, assessment, assignments, exams, etc. Judgment methods are shaped from the previous results. Only summative assessment. No assess, feedback, improve loop can be implemented in the traditional education. But in case of outcome-based education, desired outcome or goals are based on the assessment. Completion of education implies the learners has achieved set goals. Judgment methods are shaped from continuous evaluation, both formative and summative assessments. The presence of assess, feedback, improve loop can be implemented with the help of OBE. The benefits of OBE for the faculty members is teaching will become far more creative and innovative career, and shaping and thinking and vision of students towards the course. The National Board of Accreditation (NBA), the Washington Accord is an international accreditation agreement for undergraduate professional engineering academic between the bodies responsible for accreditation in its signatory countries and regions. National Board of Accreditation gives accreditation for higher educational institutes in India. This accreditation can be carried out in two categories. Tier 1 institutions consist of all IITs, NITs, central universities, state universities, and autonomous institutions. Tier 2 institutions consist of affiliated colleges of universities. And the key terms related to OBE are the course. It is a theory cum practical subject studied in a semester. Example, take engineering physics, computer organization and architecture, programming with objects, etc. Course outcome. A course outcome is formal statement of what students are expected to learn in a course. When creating course outcomes, remember that the outcome should clearly state what student will do or produce to determine and or demonstrate their learning. Course learning outcome statements refer to specific knowledge, practical skills, area of professional development, attributes, higher order thinking skills, etc. The next term is program. It is defined as specialization or discipline of a degree. So, for example, consider BTech, MTech. Next, program outcome. A program learning outcome is broad in scope and be able to do at the end of the program. POs are to be the line with the graduate attributes as specified in Washington Accord. NBA has defined 12 POs. The PO1 is engineering knowledge. Apply knowledge of mathematics, science, engineering fundamentals and non-engineering specialization to the solutions of complex engineering problems. PO2 is problem analysis. Identify, formulate, research literature and analyze complex engineering problems, reaching substantiated conclusions using first principles of mathematics, natural sciences and engineering sciences. PO3 is focused on design and development of solutions. Design solutions for complex engineering problems and design system components and processes that meet specified needs with appropriate consideration for public health and safety, cultural, societal, and environmental considerations. Next, PO4 is conduct investigations of complex problems. Use research-based knowledge and research methods, including design of experiments, analysis, interpretation of data, and synthesis of information to provide valid conclusions. PO5 is modern tool usage. Create, select, and apply appropriate techniques, resources, and modern engineering and IT tools, including prediction and modeling to complex engineering activities with an understanding of the limitations. PO6 is the engineer and society. Apply reasoning informed by contextual knowledge to assess societal, health, safety, legal, and cultural issues and the consequent responsibilities relevant to professional engineering practice. PO7 is environment and sustainability. Understand the impact of professional engineering solutions in societal and environmental context and demonstrate knowledge of and need for sustainable development. PO8 is ethics. Apply ethical principles and commit to professional ethics and responsibilities and norms of engineering practice. PO9 is individual and teamwork. Function effectively as an individual and as a member or leader in diverse teams and in multidisciplinary settings. PO10 is communication. Communicate effectively on complex engineering activities with the engineering community and with the society at large, such as being able to comprehend and write effective reports and design documentation, make effective presentations, and give and receive clear instructions. PO11 is project management and finance. Demonstrate knowledge and understanding of engineering and management principles and apply these to one's own work. As a member and leader in a team to manage projects and in multidisciplinary environments. PO12 is lifelong learning. Recognize the need for and have the preparation and ability to engage in independent and lifelong learning in the broad context of technological change. So these are the 12 POs defined by NBA. Next key term is program educational objectives. Program educational objectives should be defined by head of the department in consultation with the faculty members. PEOs are a promise by the department to the aspiring students about what they will achieve once they join the program. PEOs are about professional and career accomplishment after 4 to 5 years of graduation. PEOs can be written from different perspectives like career, technical competency, and behavior. Generally, there should be 3 to 5 PEOs are recommended. Next term, PSO. PSO is program specific outcomes. Program specific outcomes are statements that describe what the graduates of a specific engineering program should be able to do. PSO written for Department of Computer Science and Engineering are PSO 1 is understand, design, analyze computer programs in the area related to algorithms, system software, web design, big data, artificial intelligence, machine learning and networking. PS42 is focus on improving software reliability, network security or information retrieval systems. PS43 is make use of modern computer tools for creating innovative career paths to be an entrepreneur and desire for higher studies. Next, vision mission. Vision mission are institute specific. Vision to bring forth professionally competent and socially sensitive engineers capable of working across cultures, meeting the global standards ethically. Mission is to improve students with an extensive and exponentially education that prepares them to excel in their profession, guided by dynamic intellectual community and be able to face the technically complex world with creative leadership qualities. So, curriculum design under outcome-based education. So, university's vision mission, program educational outcomes, program outcomes and course learning outcomes. So, this is the top to bottom is the design approach and bottom to top is the assessment approach. So, here PEOs can be designed with working with graduate attributes. PEOs can be working with graduation attributes. Course learning outcomes can be dealing with learning attributes. Next is the Bloom's taxonomy. Bloom's taxonomy is a tool to help you to assess the level of your students are experiencing in your course. To consciously and internationally address the level of cognitive complexity and challenge in a course. Bloom's taxonomy is an excellent framework providing multiple points entry. Bloom's and colleagues in the 1956 created 3 learning taxonomies: cognitive domain, affective domain, psychomotor domain. The levels of Bloom's taxonomy. The Bloom's taxonomy can be considered as global language for education. So here 5 levels can be considered. Remember, recognize the recalling facts, understanding what the fact means, level, applying the fact, rules, concepts and ideas, analyze, breaking down information into components parts, evaluate, judging the value of information or ideas, create, combine parts to make a new whole. So, level 1 is the remember, level 2, the sample words in the level 1 is define, find, how, list, etc. Level 2 is understand. The sample words are classify, compare, contrast, etc. Level 3 is apply. The sample words are apply, build, choose, construct, etc. Level 4 is analyze. The sample words are analyze, assume, categorize. Level 5 is evaluate. The sample words are agree, appraise, assess, etc. Level 6 is create. Sample words are create, construct, develop, estimate, etc. So, relationship and mapping of CO to PO. So, here, while framing the CO, the format can be student will be able to plus behavior plus resulting evidence. For example, consider the course learning, one of the course learning outcome of computer organization and architecture. Make use of number system for data representation and binary arithmetic in digital computer. The CO characteristic can be observable, measurable, rather than they specify an action that is done by the student rather than the faculty members. So the key attributes for assessing POs. PO1 contains the three key attributes or vital features. The PO1 is engineering knowledge. 3 key competencies are identified in the PO1. PO2 involves 10 vital features like problem or opportunity identification, problem statement and system definition, etc. PO3 consists of 10 vital features and it is concerned with the design and development of solutions. The key features or vital elements are like investigate and define a problem, understand customer and user needs, etc. So like that, for each PO, the number of vital elements can be defined. So how to map the values for CO and PO? Select the action verb for a CO from different Bloom's levels based on the importance of the particular CO for the given course. You need to justify for making of the values in CO PO articulation matrix. So here 2 assessment methodologies are there, direct and indirect assessment. Direct assessment is a professional makes a decision regarding what a student learned and how well it was learned. Examples: faculty evaluated papers, tests or performances. Indirect assessment, the student decides what he or she learned and how well it was learned. Examples: surveys, teaching evaluations, etc. Assessment of program outcomes. So here PO1 is engineering knowledge. The strength or the vital features is 3 and it is assessed by CIA or SEE. PO2 is problem analysis. Strength is 3. It can be assessed with CIA or SEE. PO3 is design or development of solutions. Strength 3. It is assessed with CIE or SEE. PO10 communication to tech talk, concept videos, open-ended experiments is the assessment methodology. PO12 lifelong learning. Strength 1. Tech talk, concept video or open-ended experiments. And PSO is the strength is having 3 and can be assessed with CIA or SEE. PSO's 2 strength is 3 and it is assessed with CIA or SEE. And now take the exam, the particular course, computer organization and architecture. There are 6 COs defined related to the course curriculum. The CO1 is illustrate interaction of components in a computer system with functional units and levels of programming languages, and it is at the Bloom's levels of understand. The CO2 is demonstrate the implementation of micro operations with the help of register transfer language and electronic circuits. So it is at the level of understand of Bloom's taxonomy. CO3 is identify appropriate addressing modes for specifying the location of an operand. It is at the Bloom's taxonomy level of apply. CO4 is make use of number system for data representation and binary arithmetic in digital computers. It is at apply level of Bloom's taxonomy. CO5 is interpret the design of hardwired and microprogrammed control unit for execution of microprograms. It is at understand level of Bloom's taxonomy. CO6 is summarize the concept of pipelining and inter-process communication for advanced processor design. It is at the Bloom's taxonomy understand level. Now, the articulation, the mapping of each CO with POs and PSOs. CO with PO1 can be matched and PO2 is also matched with CO1 PO3 is also matched. And PSO1 is matched and PSO2 is matched. Like CO2 is matched with PO1, PSO1 and PSO2. CO3 is matched with PO1, PO2, PO3, PO4, PO10 and PSO1. CO5 is matched with PO1, PO2, PO3, PO4, PO10, next PO12, PSO1. So like this, the mapping of each CO with POs and PSO can be carried out. Now justification for each CO-PO mapping, a table can be developed. For example, consider the CO1. It can be mapped with PO1, PO2, PO3, PSO1 and PSO2. So what are the vital elements that matched for can be written in the justification for mapping? Student will be able to understand various functional units of computer with computer science principles. So number of key competencies can be 1. Like this, for each mapping relation of CO, PO, PSO can be justified. The total count of key competencies for CO mapping, a table can be developed. The CO1 can be mapped with the PO1. Total 3 key competencies are there for PO1. CO1 is mapped with only 1 key competency. For PO2, total 10 key competencies are there. CO1 is mapped with only 2 competencies. For PO3, total 10 key competencies are there. CO1 is mapped with 4 key competencies. So like this, the total count of key competencies for CO mapping, a table can be developed. Next, the percentage of key competencies for CO, PO, PSO mapping can be done. So here CO1 is mapped with PO1 with 33.4% and with PO2 20%. Like this, the percentage of key competency for CO, PO, PSO mapping can be formulated. So CO and POs on the scale of 0 to 3, the articulation matrix can be developed based on these rules. And here 0 is being no relation, 1 is being low relation, 2 is being medium correlation, 3 is with high correlation. So here 0, the percentage is lies between 0 and 5%, no correlation. So 5 to 40% low or slight, from 40 to 60% moderate, and 60 to 100 substantial or high relation with a value of 3. So based on that, the articulation matrix can be developed depending upon the percentage of relation key vital element that is calculated. So CO1 is having the 1 with the PO1 and 2 with 1 with the PO2, 2 with the PO3. So like that, the correlation between the vital CO and PO, PSO can be developed and represented with the help of articulation matrix. So the average of the correlation can be taken and the criteria can be, if at all it falls in the 2.3 cadre, it can be the moderate relationship. If at all it is at the 2.63, it is the high correlation. So this is the outcome based education related to the computer organization and architecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.